Hello students, welcome to EduSim. In this video we are going to discuss about lateness and we are going to minimize the lateness, the maximum lateness which we are getting. We will actually minimize using greedy approach. Okay. So before that we should discuss about what is lateness. In real life example, I'll tell you. Suppose I ask you to come within 5 minutes to my chamber, you should be reached within 5 minutes. Suppose you reached at my chamber exactly at 4 minutes. Definitely, I told you within 5 minutes you have to come and you have reached within 4 minutes. So definitely it is, you can say in a real life, we can say no let, means zero let. But in mathematically, in theoretically, you can say it's minus 1 second, within minus 1 minute you reached. So it's not good at all when we are saying. So we say better there is no let. Okay, which is zero lateness. Or else you can take another example. I told you you have to reach within 5 minutes in my chamber and you have taken suppose 6 minutes. So in that case you can say 1 minute late. Why? Because I told you within 5 minutes you need to reach at my chamber and you have taken 6 minutes. So 6 minus 5 is 1 minute. So in that case we will also discuss how lateness could be discussed using the key terms. Okay, so let us start. So before going to start with the topic, I must say I have followed this algorithm design book written by John Kleinberg and Eva Tardos, and this is a chapter 4. I collected the information from this book, so that's why I should have to discuss. I should have to give them credit as well as I must say those who are watching videos kindly read the books before before reading from this video. You first please go through one time at least from the book, that will clarify your doubts first. Okay, or if there could be any doubt being still not yet solved, then you can check my videos, detailed videos. In the detailed videos we are going to discuss what are there in the algorithms, what are there the examples could be solved, as well as we will be discussing in the problem solving, like how we will write the answers. Okay, so as for this minimizing, we must know what are the key terms we are using here. Single research processes, one job at a time. We are going to discuss like there are certain jobs. As per the example, there are up to 6 jobs we kept. Before that we should know what is TJ and what is DJ. Okay, TJ is a processing time. Before that we know S of J is start time or starting time. Okay, F of J is finishing time, or else you can say it's a finish time. Sj is starting time or start time. Okay, and T of J is a processing time, D of J is a due time, means uh, the maximum time is given as, like I told you, you have to reach within 5 minutes. That is what I told you. The DJ in our case is uh, 5 minutes. Okay, and you reached, whenever you are reaching, that it will take support based on the speed. Clear? If you know your speed is, you can manage with this distance within suppose 3 minutes, but due to certain probability uh, might be suppose you are using vehicles, or suppose you are talking to your friends during that time, definitely it are the it could create the lateness, or it will create a let for your problem. So in real life we may face such issues. Okay, we have to reach within the time that we know. And suppose in a class, in a regular class, we know class will be supposed within 5 minutes the class will begin. Okay, in that case within 5 minutes, and you know you are at home, and whenever you will start the vehicle, or might be when you start reaching or approaching to the class, might be it will take 5 minutes maximum, but due to traffic might be a problem could occur, or due to certain problems like circumstances like lift is not working. So in that case definitely you'll face the problem, like you can use the stairs, So that is what the processing time. The processing time is 2 minutes. That you can reach within the class is 2 minutes. Wherever you will be, like based on your speed, you can reach. This is what a TJ is. Okay, this is TJ, and the deadline will be started exactly. This is what, as for the timing of the class, we must say it will be starting within 5 minutes. Means you will reach within 5 minutes. That is what D say. Okay. So processing time means you will definitely reach within that time. DJ means it should complete within this, but there are many factors could apply. Many factors could be visible. So in that case, what is happening? Like the lateness could increase. Okay. So here for J, job J, TJ is a processing time. The due time is DJ. Next, J, the start time is SJ, and the finishing time is F of J. And Fj is also being carried out, like we can find out using S of Sj plus Tj. Like the processing time, the starting time, we can find the finishing time also. And lateness, which we are going to discuss. So the small l j, maximum 0 and f of j. Why we are saying, why we are taking the maximum function? The main reason is we cannot say, suppose you are within, like I called you, you have to reach within 5 minutes and you restart 4 minutes. So we cannot say you have taken -1 minute. We cannot say that one in real life scenario. We say no let or 0 let. For that reason we are using this maximum function to make a round value. Okay, either 0 or some positive value. To say some positive value, we are using this max function. Okay, to get the positive value only. Negative value will not be accepted. Now the goal is said to be, we schedule all the jobs in such a way that we will minimize the minimum latency, which is air. Okay, the maximum latency will minimize the maximum latency. What is maximum latency also we'll discuss from this example, don't worry about it. First of all, we should know the schedule all the jobs minimizing the maximum latency, which we found. Maximum latency here we discussed is, there are definitely latencies, might be 1 2 3 4 5, many lateness that we found. In based on the lateness, what exactly we are finding, the maximum lateness which we found, that should be minimized well. Okay, means suppose the lateness has 0 0 0, somewhere we are finding the lateness is 2. In that case we can say the lateness 2 should be minimized to some value which should not be greater than 2 or equal to 2. We should minimize that one. As per the example you just check, here the jobs are 1 2 3 4 5 6. There are 6 jobs. Based on that, these are the processing time we have set, and these are the due time, means within that time it should be completed. Okay, TJ and DJ has been given to you. Just for an example, we have focused here, like based on the processing time, means the time it will take to complete. Based on that, we are going to just verify whether how to find the lateness. Just for that example we used it. So as per this, the minimum is 1, next minimum will be 2. Okay, like that we will sort it first, means we will be doing one by one at a time. So here in this format we will found out, like the D3 means this is our third uh, job could be selected first, through which we can say the starting time, though we know the starting time of always the first program will be start, or the first job will be from 0, and the finishing time will be like, as we discussed here, f of 3 would be 0, though it is starting time, s of 3 plus t of 3. T of 3 we found as 1. Okay, 1 is t of 3. So total would be f of 3 is equivalent to 1. Clear? No? This is what we found. This is f of 3. This is s of 3. And d of 3 is 9. So here to find the lateness, we know maximum function is written where 0 minus f of 3 minus, here it is clearly written f of j minus d of j, d of 3. So you can say maximum function within that it is written 0 comma the function we ended with a 1, like finishing time we ended with 1, minus 9, then maximum 0 comma minus 8. We know the maximum is 0. This is why we can say the lateness is 0 here. Okay, so lateness I must say small l 3 is 0. Okay, it's not visible. I must say small l 3 is 0. Okay, which is being said as lateness. Okay, lateness is 0, we have found out. So like this here, next would be like 1 then 2 and 2. There are two options, you can pick any of this, but as per the answer, as per the example, they have taken the second job. Okay, so you can pick the sixth job also, not an issue, but as per the second job they found the finishing time is 3 and the due will be like within 3 seconds it completed, but it has maximum of 8 seconds. So these are think these are the seconds. Okay, within 3 seconds it has been completed. Here this is completed, the second one is completed within 3 seconds, and it must be completed within 8 seconds, so definitely there is no late. Okay, so here the lateness is 0. Okay, so in this case it has to be submitted or might be completed within 15 seconds, but here we complete it in 5 seconds, so lateness will be no negative, so that's a positive. We can say it's 6 would be 0. Next here, in this case what we found, 8 minus 6, maximum of 0, then finishing time is 8 minus 2, these are considered as the lateness is 2 now. Clear? Next for this D5 we must say lateness is 0. Why? Because 11 minus 14, which is minus 3, like within 14 seconds it has to be completed, but within 11 seconds it already been completed. So this finishing time is written in x-axis, and within this the due time has already been written. So due time is more than the finishing time, means don't worry, you are actually on a safer side. Okay, next for this lateness we must say maximum 0 comma the d is 19 and finishing is 15, means within 9 seconds you have to complete, but it took 15 seconds to complete. So this is the lateness we found is 6. So 2 and 6, the maximum we found is 6. That is why we can say maximum lateness. So our target is to reduce the maximum lateness, which we got as 6. That should be less somehow, uh, not 6, but somehow it should be less. But how we will get it? There are algorithms and approaches also there, but first of all we'll discuss about the approaches. In the first approach, we can focus on the shortest processing time first, means the shortest processing time will be selected first, as we have done recently. Okay, so and second point is earliest deadline first, means the deadline which we got as earliest, means when it will be completed before, that will be considered first. Okay, next is third option, you can say smallest slack time. What does it mean? It is due time minus the processing time, means the number of time it actually completes, or inside a process, like how we exactly reached, like for a task, that is what called as slack time. And we have also counter examples for it. You can check which one to be selected, why we are not selecting that one. Recently we discussed the shortest processing time first, means the tj if shortest, that we will discuss. You can say, suppose here the timeline is fixed somehow, so these are a timeline 1, then this is 100. Why? Because the shortest will be selected first, so the first job is selected, and it will be ended with 100. So you can say the d of 1 is the d of 1 is 100. We can say here we can definitely reach just mistake that I've done. Here the starting time we start with a 0. Okay, here as per the example you can check the finishing time will be starting time plus uh, processing time. The processing time is 1, so you can say as per the processing time, so the lowest processing time will be fixed past, so 0 to 1. Okay, now it's 0 to 1, which is the first one, so it will take the finishing time as this. So d of 1 is 100. So where we can say f of that the finishing is always less. If it is always less, so we'll say let less is 0. You can say here as per this function finishing time should not be greater than d of j. If it is greater than this, so we must say there will be lateness. Next, second one will be 10. So if I'll add 10 here, you can say the second d of 2 is 10, and the finishing time will be 1 plus 10 equal to 11. But it has to be reached by 10, so it is beyond that. So maximum lateness would be, or lateness would be, you can set 0. Finishing time is 11 minus deadline which we have defined is 10. So as per this we got, this is our lateness. Okay, that should not be maximum, but in this case it happened. Okay, another case we said the smallest slack time we have decided, so dj minus tj will be selected. So for this the is slack time is 0. Why? Because the 10 minus 10 is 0. Slack time is 0, and here the slack time is 1 because d is a minus processing time we found. So based on this, what we say, we started with 0. Okay, process 2 we started from this. First project, so task. So here we started from 0 and we ended with this one. So d2 will be 10, no lateness, but here d1 is 2, so lateness would be 9. Minus this is 11, maximum is 9. So to avoid or to give minimum lateness, what we are doing, the algorithm is written that should be based on earliest deadline first. Okay, n number of jobs we have to first sort it using this deadline, which will take big of n log n base 2 as per the heap sort. Okay, here we introduced t. Okay, which is a starting value, you can say, through which we means whenever we are starting the job which want to be selected first, based on that we must say 0. Now we run for loop, then assign job j to the interval. We have set the interval like 0 means we started with the 0, that means we started with the 0. This is our starting one, that's why we have written it will take big of 1. The complexity why it is one line that we have written or one sentence. Then 1 to n, number of jobs we set as n, that's why we are writing it. Next assign j in such an interval. What? 0 plus the processing time that we recently discussed. This is the f of, this is what we studied as f of j could be written as s of j plus t of j. This is what it is written. Okay, so in this way we have written the answers. Now this s of j is t and f of j is this one which we recently discussed, and next t would be upgraded as t plus tj. Okay, now output could be in interval format. Okay, because we are focusing on each job one by one job, that is why we are expecting in such a way. And better I'll change the color of complexity through which it could be better to understand by you. Okay, while discussing the time complexity n log n base 2, why we are using heap shot and base 2, because of there are two children we are keeping. It's a almost complete binary tree. For that reason we go for 1 because it's a statement, and within that it's for loop is running, and this is also big of 1. A single statement is written, or this big of n plus 1. Why? Because for stopping condition, you can say it's a stopping condition. Stop condition, how? J is greater than n, then we'll stop. So for this, the time complexity could be big of n log n base 2 plus big of 1 plus big of n plus 1 plus big of 1. This could be written as big of 1, not an issue. This 1 is equivalent to big of 1, not an issue. So out of this, the maximum is big of n log n base 2. This is maximum. That's why we can say the time complexity is, I must write there, 1. Okay. So the time complexity we can write is n log n base 2. This is the time complexity which we got. Okay. Now I'm changing the color. Here we started with the earliest deadline. Okay, here the deadline we found earliest as here, because 6 8 9 9 14 15 we sorted it first. Once we have sorted it, as for the sorted, we are doing the job now. So here I have focused here like 6, the tj is 3. So before that we started from 0. As for the example, though t started from 0, so it's t now, it started from 0, and next f of is 0 plus t of j, which is said to be 3. So f of will be 3. It will complete it within 3 seconds. Let us take for that example. So here we started with 0 and we ended with 3. So to find the lateness, we must say maximum of 0 comma the finishing time minus the deadline. Here it is minus 3, maximum 0 comma minus 3. So the lateness is 0, so we don't bother about, because we know our target should be minimize the lateness, or you can say minimize the maximum lateness. This is what our goal is. Okay, next will be 8. The next deadline we have to pick is 8. Okay, as per this we found the processing time it took 2. So previously it was 3, so 3 plus 2 is 5 we found. Then we must say whether it is lateness we can say or not. The lateness we can say if finishing time is more than d2. Here we know finishing time is less than that. I told you have to reach within 8 minutes and you reach by 5 minutes. This is what the lateness will be 0. Next 9 9, you can pick any of this, not an issue, because deadline if equal, so you can pick any one, any of this. So out of this example we can say, so 3 is picked first, but whenever you're focusing on this equal, I must say I must want to add the processing side should be less will be picked first. Why? Because there might be a problem of increasing in lateness. For that reason here it is not added. So I must say you should add if deadline are equal, in that case you pick the less processing time first. Okay, so as per this, it was previously for this processing time is 1, so 5 plus 1 is 6, so 6 is less than the deadline which has decided, so lateness is 0. So for this, L1 is 0, L2 is 0, L3 is 0, L4 is like we have to in 4 will be the maximum we can expect. So 6 plus 4 is 10. So here 10 is greater than the deadline which we decided. As per this maximum, we can say maximum 0, 10 minus 9 which we got as 1. Okay. So here the maximum lateness or lateness till date we found is 1. In this case D5, though it is 14. Next D6 will be selected. First with D5 we have to add as per this processing time tj. So it was previously 10, 10 plus 3 is 13. So now the finishing time is less than d5, so no lateness. Your L5 is 0. In L6 we must say it is 0 because finishing time of that job is equivalent to the deadline. Okay, if it is equivalent or less, definitely we say lateness is 0. Otherwise the lateness could be some positive number. Okay, so the note we have to remember is for both interval scheduling and interval partitioning, I must say first interval scheduling, we are focusing on shortest finishing time or finish time, which is f of j. Okay, for interval partitioning the same we are using. We are focusing on shortest of start time first, which is s of j. Next lateness, minimize the lateness, we are following earliest deadline or due time, you can say deadline first, which is d of j. So here j is the uh, task. Okay, so you should remember the algorithm might be in question. You can expect the algorithm could be written and it may ask you like where you can change through that. It will be giving you the optimal solutions, or the goal could be fulfilled, or might be the program will be means the algorithm will be written, which type of algorithm it is, like what it is doing, can you improve it. So in that case might be the questions could be asked. So I hope it is understood by you. If any issue you can comment below. Thank you, have a good day.